Hello again. As you know, I'm Eli the Computer Guy, and this is episode 328, Introduction to Virtualization Infrastructure Design. So as I talk about in the real world, the problem that I have with new technicians, and the big problem that new technicians have, is although they understand how to do the configuration settings for technology, things like virtualization, they don't really understand why they are using it or what they are supposed to do. So this is not going to be a technical episode. I'm not going to be opening up any control panels, but we will be going over to the whiteboard so I can discuss, I can talk about how you design your virtual infrastructure and why you would do it. So back in the old days, 10 years ago, whenever we would build out server rooms or whenever we would build out infrastructure, every single server was connected directly to the hardware. So if we wanted an Active Directory server, we had a physical Active Directory server. If we wanted an email server, we had a physical email server. If we wanted some other type of server, we would have a physical server. So when you would walk into a server room, many times you would see anywhere between 3 to 10 servers all doing their own thing, and that is how we would build server rooms. It was very good for the time. It worked very well, but now that we have virtualization technology, it's now not as good as it used to be. We can buy far less hardware and have much more secure, robust systems than we could before. So before, if we wanted 10 servers, that meant we actually had to have 10 physical boxes, 10 physical servers in that server room. Now if we want 10 servers, we may actually be able to put all 10 of those onto one physical box. That means that we can save money. It's easier to configure. You don't need as much physical room to store it, so on and so forth. If we use Type 1 hypervisors with high availability, we can connect multiple physical servers and then have instances of the operating systems be able to bounce around on those physical servers at will. So with these new types of technology, we can do things nowadays that we could not do in the past that can make our systems more reliable, more secure, and less expensive. And remember, the less our clients spend on the hardware, the more they can pay us to configure the hardware. So in this episode, we're just going to be talking about how we build out this infrastructure and the reasons for why we do it. So let's go over to the whiteboard so I can explain some of these things to you. So talking about virtualization right now, basically we are going to be talking about Type 1 hypervisors. So when we're talking about Type 1 hypervisors, we're talking about bare metal hypervisors. So this is not VirtualBox. This is not Virtual PC. These are things like ESXi, or Zen Server. Basically what happens is you have a box, you install ESXi or Zen Server onto that box, and then you install the instances of your operating system directly onto ESXi or Zen Server. There's no Windows here, there's no Linux as you would know it, there's no Unix as you would know it. A Type 1 hypervisor is a kind of operating system, but all it is used for is to control these instances of virtual operating systems. We did the episode on Type 1 hypervisors. Basically how this is controlled is you have another computer somewhere else that is called the manager computer or the management computer. In VMware, you use something called vSphere. This connects to the Type 1 hypervisor server to actually control all of these different instances of operating systems. So when we look at this, the first reason that we may think of using Type 1 hypervisors and building out a virtual infrastructure is simply so that we can have a number of different operating systems running on one single piece of hardware. Now you may be asking why this is. Why would we want numerous different instances of operating systems running on one piece of hardware? Well, if you know anything about security now, if you know what to worry about with hackers, what you realize is that the more capabilities a server has, the more vulnerable the server is. So no matter what server software you're using, whether you're using Active Directory or FTP or VPN or Apache Web Server, all of those provide specific functions, but they also have specific vulnerabilities. So the problem is if you have one box over here that has both Active Directory and it uses IIS, which is Windows Internet Information Services, and let's say it does some kind of FTP, the problem with this design, if this is all sitting on one box, is if somebody can compromise the IIS server. So the IIS server is a web server, so www. So somebody comes in from the internet cloud, they're able to get into the IIS server, they're able to compromise that somehow. Well, once they've compromised that IIS server, they can now attack your Active Directory, they can now attack your FTP, they can now attack any other services or anything else going on in this server because it's all in one box. If they compromise the Active Directory, they also compromise the IIS. If they compromise the FTP, they also compromise the Active Directory. So since all of this is on one single box, it has all this functionality, but it also has vulnerability. So remember that whenever you're dealing with servers, the more functionality the server has, the more vulnerable the server is. So the reason that you would want numerous instances of operating system on one piece of hardware is because that means one instance can be an Active Directory server, one instance can be an IIS server, and the last instance can be an FTP server. So you can now divide these out and have these services running as their own individual servers on the same hardware. So if a hacker gets in and compromises the IIS server, the Active Directory server is still cocooned within its own virtual machine, and so it can't easily be hacked from the IIS server. Same with the FTP. So the reason you divide these out into their own instances of operating systems is to secure them. The less each individual server does functionally, the less vulnerable it is, which then protects your overall system. Again, if you have all this stuff built on one box, one server, one thing gets compromised and it takes everything else down. By having these individual instances, one, you limit the overall number of vulnerabilities, and then even if a hacker gets into it, well then, it only compromises that one instance of an operating system. It doesn't compromise everything else. So that's the first reason you would do this. So like with this one piece of hardware, you can make this, literally have, 20 gigs of RAM, which would be more than enough to run all of this. And this one little box is only going to cost you like $1,500. So for $1,500, you can get one piece of hardware, you can put on some virtualization software, blah, 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 and you have a nice little robust system here. Now, as we've talked about, so that's why you would do it from a security standpoint. Now, from a robustness standpoint, what you can do is you can then connect numerous physical servers and have them managed with vSphere or ESXi so that these instances of operating systems can be migrated at will or migrated automatically. So let's say that the power supply in this particular server fails. Well, with virtualization, what can happen is if the power supply fails, these servers will automatically be moved to a different physical server, and everything stays running, and many times the end users don't even realize it happened. So before, remember when we're talking about those 10 servers all sitting in a rack, if the power supply for the Active Directory server failed, Active Directory failed for the business. It was down. Well now, since we can cluster these servers in this whole virtualized environment, if the first server, if the power supply in it physically fails, it can simply migrate the instance of the Active Directory server to one of the other pieces of hardware in the cluster, and then it keeps running. Not only that, but depending on what management software you are using, you can use this to migrate servers as resource load increases. So now with businesses nowadays, we all keep talking about the cost of energy keeps going up. Electricity bills keep going up and up and up and up and up. Well, these servers, especially one-use servers or powerful servers, eat up a lot of energy. One of these servers may eat up to $500 of electricity per year. If you have 10 servers in a rack, that's $5,000 in electricity alone, right? Now, as you know, most of these servers the servers, the operating systems, don't need the full utilization of the hardware all of the time. So when people come in the morning and they start logging into the Active Directory server, that spikes the resource requirements that Active Directory server needs for a short amount of time, and then it goes down again. So this Active Directory server, for about half an hour every morning, may need 5 gigs of RAM. For half an hour. For 23 and a half hours every day, it needs 1 gig of RAM. Well, what you can do with the management software is you can actually have these other pieces of hardware powered down or in a hibernate state so that they don't burn up electricity. As soon as one of your servers starts needing more resources than the physical piece of hardware it's currently on can cope with, this instance will automatically be migrated to another piece of hardware. So this piece of hardware will actually be turned on automatically, and the Active Directory server will be migrated to it automatically. So it'll go along for 30 minutes or 40 minutes for an hour until the resource requirements go back down to where it can manage on the first piece of hardware, and then it will automatically migrate back, and this server will be powered off and shut down. So again, as I tell you guys, the entire brand of Eli the Computer Guy, I am not simply trying to teach you technology from the standpoint of a consumer or prosumer. You're supposed to be IT professionals. IT professionals have to worry about more than simply what antivirus to buy or even what hypervisor to use. You guys have to worry about things like power consumption. So $5,000 a year, that's a decent amount of money. And that's for like 10 servers. What if you have 20 servers or 100 servers? So you have 100 servers running 24 hours a day. That could be $50,000 a year. By simply using some of this virtualization technology, for $25,000 in software licenses for this virtualization technology, you could have a return on investment. You can make all your money back within 6 months. So that's one of the things to think with it. So when we're dealing with a virtualization, the first reason we divide everything off into instances is for the security component. And then why we use these type 1 hypervisors is for the robustness. So if one physical piece of hardware fails, everything just gets migrated to the other piece of hardware. The final thing that we need to be thinking about, or one of the last things we need to be thinking about in this whole virtual infrastructure environment, is that again, as we start going to cloud computing, what we are trying to do is we are trying to separate all of the computing functions away from the hardware. So again, back in the old days, if you had a file server, that file server ran the operating system and stored the data and all of that. Again, if the power supply failed, everything failed. Well, the idea with virtualization is we're trying to separate all these things out for security and for robustness. So one of the ways that this is done now is especially with Zen Server. So Zen Server is by Citrix. When you set this up, your instances of the operating system actually run on these different pieces of hardware, but the data is stored over here, generally in something called a SAN, a storage area network. So when we've been talking about virtualization here, we've been talking about instances of the operating system, virtualizing the operating system. Well, with SAN, what a SAN does, a storage area network, is it sends data over numerous pieces of hardware that are used for storage. Kind of think of SANs much like RAID, redundant array of inexpensive disks. You know how you do redundancy in a single computer for your hard drives. Only if you're using entire physical boxes. So these are individual computers that are set up in a SAN. The data is automatically migrated and made redundant through all these different servers. So if one entire server fails, you still have all of your data. Depending on how the SAN is set up, maybe if 2 entire servers fail, you still have all of your data. So SANs are clusters of servers that just store data. So what we can do now is these instances of the operating systems and the hypervisors, they connect to the SAN using something called iSCSI. That's its own class. We'll talk about it later. Basically, this is a protocol for being able to send data over networks, but what makes it special is you can actually mount the drives in the SAN. So as far as these instances of the operating system are concerned, their hard drives are actually here on the SAN. So with this, we now have the complete redundancy of all the data, and we have the redundancy and the security and the reliability of all these instances of operating systems. So now with a little bit of planning and a lot of work to set this up, we now have a very robust system. Our data is stored on a SAN, which is multiple pieces of hardware that store the data. If 1 fails, it stays up. If 2 fails, it stays up, depending on how it's set up. 2, 3, 4, 5, 6. You may have a SAN that has 2 servers in it, or 10. It all depends how it is. But that's completely redundant. Then we have the virtualized, the type 1 hypervisors. They are redundant. They can move the instances of these operating systems around at will, and it's all very good. So basically, with this virtualized environment, we can have numerous different instances of the operating system. It can all be secure, blah, 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 blah. Now, the final thing with how we set up these virtual servers is, again, remember, the less a single server does, the less vulnerable it is. So the more stuff that is on a single server, the more vulnerable it is. How we talked about how we had this one server with Active Directory and IIS and FTP. If somebody compromises the IIS, the Active Directory goes down. Well, one of the issues too, when you have servers like this, where everything is on one server, is things like the firewall. So instead of having a couple of ports open to the outside world so that the server can communicate, you have to have the ports open for all these different network services. The more ports you have open on a server, obviously, the more vulnerable it is. Well, when you start dealing with the enterprise environment, you want your servers to be as not vulnerable, as secure as possible. So when we talk about those instances of separating out the services onto different operating systems, the reason we do that is because let's say we have a web server, right? And so that web server is connected to the internet. So we have our router, and then under it we have our web server. And so normally when you're thinking about this web server, you're thinking it's going to have Apache on it, you think it's going to have MySQL on it, you think it's going to store data, so on and so forth. But again, the problem with this is if somebody can do a SQL injection properly, they can compromise the server and everything else on it. If they can get in there and screw with the Apache or screw with the data, they can compromise this entire server. So what they do is in a layered network, what they would do is they would install Apache on this server. Actually, they would install Apache too. So whenever anybody comes from the outside world, they would get to this server and the Apache 2 would be installed on it. Then what they would do is if you were dealing with a website that connects to a database, you would actually build an entirely different server. So in this instance, we would create an instance of a server that just had the MySQL database. You would then connect through the web programming, your web program to the MySQL database on this server. But the thing is, with this server, we can now shut down all the ports we don't need. So we can only open the ports that we need for MySQL to talk to the web server, and on those ports, on the local firewall, we can also say that we will only talk to this web server. So if somebody tries to come in and tries to hack and tries to connect to this MySQL server, we've set up the firewall so it will only talk to the web server. So if you come from the outside world and you come to the web server wants to run a query. So it goes down, asks the MySQL server for the information. MySQL server responds back to the Apache server, and the Apache server then sends it back out to the user on the internet. If somebody can try to come in and compromise the local area network, if they try to get to the MySQL server from the local area network, that connection will fail because the firewall is configured to only talk to the web server. The same can be said for whatever your FTP server. So if you have a file server, all the data would be stored on the file server. The Apache server asks for the data. When it gets it back, it then sends it up to the web and whoever's using it. So this is one of the ways that you can secure your network. Again, it makes it more robust, more stable, so on and so forth. What you have to remember is the less your server does, the less vulnerable it is. The more your server does, the more vulnerable it is, and it's almost exponential. It's not simply that if you have one vulnerability because you have Apache on the server and then you put MySQL on it, that means the level of vulnerability is 2. It's more like the level of vulnerability is 3 or 4 or 5. The more stuff you put on the server, it exponentially gets more vulnerable, and therefore people can attack it. So this is why it's great to have these instances of operating systems on a hypervisor, because I can just have one hypervisor here, and I can have my web server here, and I can have my MySQL server here, and I can have my FTP server here. I can set up the firewalls to communicate between all of these. And again, if somebody compromises the web server, MySQL is still okay, FTP is still okay. If somebody compromises the FTP, everything else is still okay. This is how it works. This is why it makes it much, much more secure, better, blah, 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 blah. I think maybe that will be my explanation in the future. Whenever anything gets too complicated to explain to you guys, I'll just be like, blah, 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 blah. Don't you understand blah? It's a blah. No. But this is cool. This is really great. Again, for a lot of you new guys, you probably don't realize how awesome this is. One of the nice parts with this too is, remember, whenever we normally buy servers, how we've gotten used to buying servers is whenever we bought a server from Dell or HP or Lenovo, it always had the operating system installed, right? Well, that operating system, a server operating system, will cost you an additional $500 to $1,000. So, if you buy servers without the operating system, then each individual piece of hardware is a lot less expensive, right? So, again, with how this works now, it can be a lot less expensive than you may realize. You can buy a very nice piece of server hardware for only $1,500. You install ESXi on it. Depending on what licensing you use, it may even be free. And with that, you can move these instances of operating systems around. You can create instances of operating systems on that one piece of hardware. So you could have one piece of hardware, use ESXi, create a 2008 Active Directory server in an instance, and an Ubuntu web server on an instance, and an FTP server on an instance, and they're all secure in their own world. Before, you would have had to buy 3 physical pieces of hardware, so it may have cost you $5,000. Now, since you only have to buy 1 physical piece of hardware and the operating system license, it's going to cost you $2,500. So these are the things that you should be thinking about. Again, any IT guy, any IT professional, as I've talked about in the past, where now you guys need to start learning Linux, you guys need to start deploying virtualization. There's still, with IT people, we still have this idea of every piece of hardware needs its own operating system. So that's how a lot of times we still function. But we need to start thinking about this virtualized world where you have the hardware and then you have all the instances of the operating system going around and doing all their different stuff. You also do need to start learning about SAN, storage area network, things like FreeNAS, for being able to store data on the network. Because again, this is going to become a more and more and more important technology that if you deploy it properly, your clients are going to be happy, your end users are going to be happy, and you're going to have a lot less work to do. So those are some of the things you should be thinking about. So, as you know, I'm Eli the Computer Guy. This was episode 328, Introduction to Virtualization Infrastructure Design. You guys need to start thinking about this infrastructure design and virtualization, because this really does change the game. When you see these commercials they have every once in a while, where they talk about the boss comes in and in his big where he used to have a big server room with 1,000 servers, he walks in and now there's like one computer sitting in a corner and that does everything. That is what we're getting to in the virtualized world. Some of these servers that you can build for even $10,000 can have over 200 gigs of RAM with massive solid state hard drives. You know, one of those $10,000 servers could host 20 or 30 instances of operating systems and have them run really, really, really well. And they'll be more secure, they'll be more robust, so on and so forth. So I enjoyed taping this episode, and I look forward to seeing you in the next one.